So biometrics is the science of recognizing individuals based on their physical or behavioral or psychophysiological traits. And so in this discussion we're looking at, well, what are the aspects of biometrics that can in fact be used to compromise the privacy of an individual interacting with the internet. So certainly as we look at the massive amounts of data that are easily accessible via the internet, we're talking about social data, we're talking about financial data, medical data, and business data, and so on and so forth. So numerous transactions are being conducted. But it's not just about the data itself, it's also about the individuals associated with this data, or individuals who are uploading this data or accessing this data. So the notion of individuals kind of permeates through this notion of data in itself. So as we look at the number of photographs, for example, that are being uploaded onto the internet, and this is mid-2014 towards the right, we see an exponential growth as to how much data specifically related to photographs are being uploaded on the web. The point here is one could use what are seemingly diverse sources of information in order to deduce the identity of who a person is. So one of the experiments that was done from by Acquisti, and which I will refer to in the next slide as well from CMU, is you have Facebook data on one hand, and then you have data from a dating site. In the Facebook, you assume that there is a reasonable, for good reasons, the true name of an individual, and in the dating site, you have pseudonyms. And by just looking at using an automated system, one could deduce and interpret what those pseudonyms are based on the information available in Facebook. Or you have a situation like the one described here, from Acquisti's work, Faces of Facebook, which is really a convergence of three technologies: face recognition, cloud computing, and online social networks. So in principle, as someone is walking down the road, and you take a picture of that person, there is sufficient amount of information on the internet which can be used to deduce who that person is. And if you were to use Acquisti's earlier work from 5 years ago, even with a reasonable error rate, determine the social security number of that individual. So certainly the multiplicity of data is very important, that even though one site might be offering good privacy, the fact that you have many other sites can actually compromise that. So one of the things that we've been working on is how do you de-identify data, specifically face images that are placed on the internet. So one of the schemes we are using is based on visual cryptography. And just to give an illustration, what you see here is individual one. And I think we know who this is. This is Washington. And then we have the second individual here, Bill Smith. I think you'd agree with me. But these two images have been slightly perturbed, that perhaps is not easily visible in the human eye. If I were to do a simple XOR operator, the real image that is present here is that of, well, my student who did this research work. So the point being that often this type of security, and I don't want to use the word security because we're trying to distinguish it from privacy, is to be able to have some kind of accountability, that one agency cannot determine who the identity is or who the person is, and unless they're in collaboration with a different agency, at which point the identity can be divulged, and so on. So these are just some simple principles and using computational methods to hide data. So in summary, we are talking about privacy-enhancing technology. I think the oft-used term is privacy by design. So we don't just want to use that, but say it's privacy-enhancing technology. That, for example, how can you preserve the privacy of a user's biometric data? Face, fingerprint, iris images, etc. So one is to prevent cross-linking across applications, not just from a legislation standpoint, but from a technological standpoint, how can we do that? It's called as cancelable biometrics. How do you prevent gleaning additional information from biometric data? So if a data is to be used for recognizing an individual, just for matching purposes, one can't use that to deduce the health or pathological state of the individual, or the gender, etc. of the individual. So you have some kind of measures to prevent that. And finally, there's a need to define privacy metrics, guarantee privacy, and develop differential privacy schemes. So finally, I just want to give a brief note here. Cybersecurity CV, you can talk to Johannes, who's there, and he'll give you some information about this, where there is a lot of information about cybersecurity researchers on campus, and we'd like you to also upload your information if your time permits. But I'll stop there. Thank you.
Hey, I see a question.
So you mentioned the number of pictures being uploaded to the internet. That's going to increase by an order of magnitude in the next decade as we get, for example, appliances that like to take selfies. And I say that somewhat facetiously, but Samsung showed, for example, at CES this year, a refrigerator that constantly takes pictures of its interior in order to gauge, to calculate and gauge the level and the expiration date of the products inside. And so you're going to see all of that stuff go on online. And that's not, I mean, that's a privacy concern, but that's also a security concern because one could manipulate that data in various ways as well.
That's right. And also the correlation of data across diverse sources to build a profile that can be used for purposes beyond what it is intended for. What is called as function creep. So that's where the danger is, and therefore manipulating data even during storage is essential using techniques like visual cryptography.
Aaron, I think I mentioned this to you before, but I think it's ironic that if we try to de-identify photograph or facial images, that's the one biometric that people are most comfortable providing.
Right.
At least historically, I think that's been the case. So if that's the one biometric that we're willing to give for passwords or whatever, then I don't know, I guess the question would be, how do we protect the ability to identify a person if we're going to use biometrics for any really important purpose?
Sure. And I think one of the, again, that's a very comprehensive question, and the way in which some researchers have addressed that is through this principle of what we refer to as differential privacy. So you're still using the face image for recognition purposes, but not for anything beyond that. So you modify the face image. One of the most recent work that we did was we modified the face image such that you can still use a face matcher in order to successfully match it with the right identity in a large database. But by just using that face image, you can't glean additional information like gender, race, age, etc. of the subject, or perhaps even the pathological ailment. So those type of differential privacy schemes, which is being borrowed from the cryptography, Professor Wren is here, is one way to address that problem.